Hey, hi everyone. This is Abhishek. Today in our video, we will be talking about what is the concepts of active cluster. So this feature from Pure Storage gives us the active data center kind of setups. So basically, we'll talk about how the storage replication is taking place across the sites, how the host level configurations can be done. So mostly in our video, we will be talking from a VMware perspective, how things can be designed, and how we can set it up from a networking levels also. And on that basis, only the application can be hosted. So to provide the active data center setups. Now, we are pretty known with the fact that we are looking for always with the high availability applications. Now, high availability, if we talk about, it does have a different methods to get it implemented. But when we are seeing the whole sets of design of our data centers, it totally depends how the data center has been designed and how it has been stretched across one side to the other side. The same concept is being also followed in any of the public cloud environment also. Like whenever we say with the concepts of AWS, high availability, or when we do have the redundancy that we have to take place across the site, we need to follow the fundamentals of the related public clouds. Now, the similar things is being also done in any kind of private cloud environment. Only the thing is that in the public cloud, we will not go into the details of it, how things are being configured behind of the scene. But in the private cloud space, uh, the related engineers, they need to set up all this set of configurations and make sure that it does give you the redundant path of placing your applications, which can be in one single site or it can be across our two sites. Now, coming back to the concepts of active cluster, this is something which I will try to explain, first of all, from a storage level. Then we will try to understand it from the hypervisor level. And then we will see from an application how the networking construct can be set it up. Now, when we talk about for the active cluster, this is basically a concept of pure storage where we get the infrastructure of two sites and we make sure that the arrays of the pure is being connected through any of the Ethernet lines. Now, it is being mostly followed when you do have two sites, and from a metro Ethernet, we do have 11 millisecond kind of timeouts. So that's the maximum that we can really go up to. If it is going beyond it, obviously we can face some trouble to form the clustering across these arrays. So ultimately, the idea is that whenever any host which is accessing the storage, it's doing the read and write. It is going to do the read and write to the respective array which is in their data center. But whatever the volumes which is being presented to that very host, that is being replicated across our other sites. So in this such cases, when we are taking a reference of site number one, so we would have host number A, which is going to mount the volumes which is being presented by the array A, which is of pure. So ultimately, host A can do a read and write to the respective data centers. So it would have one path to reach to the storage, but ultimately, with the configuration of Pure, we can also make sure that this host A will have the another redundant path that will go via either from fiber channels or maybe via Ethernet. And the same replica set of configurations is being done for the host number B. So host B will also have the connectivity to the local data store, and it is made sure that the volumes which is being added, this comes into the stretch group. So the idea is that whenever any of the host reads and write, or whenever it deploys any application, which can be in form of virtualized, format, maybe in the method of VMs, or maybe it could be a physical server. So the idea is that it's going to read and write the data, and all this data is being replicated across the site. And this is something which is an ongoing process. It's not like on a specific time only the replication will take place. And this is the whole thing which we call it as an active sets of cluster. Now, with this particular method, what we will be expecting, if we have the isolation of this host, or if I do have isolation of complete of the site, host B, from a virtualized or maybe from an application point of view, if it has been formed into the cluster, we are not going to lose any such data, because the data which has been replicated via site one, that has been already replicated on the other end. So this is something which is being configured on the pure level, and this is the set of volume, or this is a set of data store which is being presented to the host, which is across our site. Now, obviously, totally depends upon your applications. What is the application demands? If an application says that, yes, I need an Ethernet connectivity across the host, so that can also can be connected through the Metro Ethernet link, or maybe it could be through the private line, which is for specific customers. Again, depends upon their related designs. But in our use cases today, we will be taking help of VMware solutions, where we are going to have host A and host B. So this will give a reference to one of the ESXi. And under the ESXi's, we will try to form a clustering between host A and host B. Assuming that they are part of the same data center, same cluster, and whatever the VMs which is part of it, it is going to be believed that it is going to spread across the site. But ultimately, with the VMware logics, you can still control the VM locations as per the need of the VM availability. But again, from the fact of clustering, it can be across any of the site. So this is something which is from the compute level, which need to be done, especially when I'm talking about from a VMware point of view. It's a basic clustering that you have to get it enabled, and the high availability solution of ESXi that you have to define on it. From the connectivity wise, obviously, when you're trying to put them into one cluster, you need to have a vSphere, vCenter, whatever name, but it's actually the vSphere server which need to have the management connectivity. Only the demand is that it should be formed, it should be configured into the cluster, but it is not mandatory that it should always have the vSphere connectivity. What I mean to say that if let it be you have put vSphere on site one, and if site one goes down, still the recoverability of the VMs will take place. Because this is something configured on the cluster level, which will allow it to get the recoverability of any of the VMs on it. But something this is not going to be fair when we talk about from the networking front. From the networking front, we need to make sure the networking logics has been configured very well. Now, we'll go back to the lab and we will try to see how our current design in our demo lab, how we have configured it. But ultimately, this is something which you have to really think about from the high availability from and as an active data centers. For an end customer, it doesn't feel that you are setting it up on two different data center locations. It will be under one DC locations only. That is the assumptions that you're going to see when you try to log into vSphere from a VMware background. Now, coming to the lab environment, I have got a simple lab which we have configured, and something which I can demonstrate today. So I do have two locations. These two locations, we will name it as HRC and KCA. These are our two data center locations. Now, these two data center locations has the internet connectivity. It does have the MPLS line, which is connecting two different sets of customer. Now, this is something for every customer. They wanted to have their private line connecting to their private networks. They can probably take the MPLS line. But there are many other methods to get connected to your any sites. You can even have the internet connectivity, and with a proper security features, you can still have the connection to any of your sites. So MPLS line, when you try to compare with any public cloud environment, it's pretty same. It's not very different. You need to just talk to your local service providers and just make sure that do you have the Express Connect or the private line features which can be connected to any private to the public cloud environment. Coming to the lab environment, just to demonstrate the routing features on the internet, I have deployed a CSR routers, which I have named it as HRC router. And the another one, I have defined it as with KCA router. I have configured a loopback IP like 1.1.1, which is giving me the relevance of internet connectivity. So for the testing purposes, I'm going to use this IP for my internet connectivity testing. Coming to down under how the VM has been deployed. So ultimately, when I'm going to explain that how the clustering is being taking place and how the migrations can, the migration network has been constructed. So we have used one set of VLAN, which is a stretch kind of VLAN across our site. So in our set of lab, we have to use VLAN 80. So this is the VLAN which is going to be used for our VTEP communication, which is basically for NSX feature. As we know from a VMware side, NSX is the another product which gives us the network virtualizations features there. For the vMotions, we can still use management network also, or else you can have another separate network for the vMotion purposes, via which any of the ESXis can move the VMs here and there in any day-to-day task. But when coming back to the VM connectivity, these both of the ESXis, we have binded into one cluster. From a networking point of view, I have put them into one single DBS and I have prepared that DBS under NSX. So under NSX, I have prepared one VNI, or I would say VXLAN, or any logical segment, which is actually spread across the sites. This is something NSX is not aware that it has been spread across the site, but from the VMware logics, it is actually spreading across the ESXis. So what this particular features gives us the feasibility that any of the VMs can be connected at any site, but it is going to get connected to the same virtual networks. So we need not to have any kind of routing across the sites. It can still stay on the same network and it can move across the site at any point of time. But coming to the routing logics, these VXLAN networks has been attached to the tier 0 routers. In fact, it can be tier 1 router also, but again, totally depends upon your design, how you want to go ahead with that. Now, coming back to the routing logics, we know that from NSX, we are going to have the edge concepts. So you can have an active site from NSX point of view, or else you can have an active standby site from the NSX side. But only the fact which we need to really understand how the northbound routing is taking place. Because if you're going to make both of your edges to be an active, so both of your edges will be capable to send the traffic up in the northbound side. But we have to really focus how our traffic is getting ingress to our data center. So that logic has to be really understood as per different cases of customer requirement. Now in our lab, what we have done, we kept one of the edges as an active and the another edge as in standby. So whatever the site which does have active edge, that's the edge which can carry the traffic to egress path. So what does it mean? Whenever any of the VMs which tries to send the traffic to northbound, these traffic will always head to the active edge itself. It is not going to head to the standby edge. But if you do have both as an active, both of the edges can receive the traffic and it can send it to the northbound to the northbound to your infrastructures. So this is something which you have to keep in mind, and you have to define the designing of it. I've seen customers being doing both as an active, but it comes with a trouble if you have any firewall on the top, because you'll not have the transit path to be same as how it is egressing. The same path can not be coming as an ingress one. So as we know, firewall can block those kind of traffics. So just to make it more simple, more method way to really achieve your, I would say, activeness, I will always suggest that keep one particular site as an active, because from the NSX point of view, NSX is going to just do the ingress part of it. Ingress is something which customer need to define how they are advertising their public network or the public IP which has been assigned to this particular VM, and how it is advertising the private network. Now, in this such cases, if you are going to see, you're going to have an active edge. Active edge is going to have the connectivity to the HRC router. In this particular lab, I have configured already BGP with AS number 65001, and the down under one have got the BGP of 65010. So I've just found the basic eBGP neighborships across the routers. So one thing that you will notice when we will go to the lab, that the active edge is going to advertise the network with a higher preferences, because this is an active, okay? But when it is going to be standby router who is going to advertise anything to the northbound router, it is going to be a less preferred path. So this is something which we will see how NSX is going to define the preferences. That is purely on the logic of BGP itself. Now, coming to the fact, the HRC routers, if it is going to have the connectivity, it must need to advertise the private network if it has got the private lease line. So this is something that can be controlled by your MPLS router on the top. Again, totally depends upon infrastructure by infrastructures, how the advertisements are being taken place. Obviously, to tackle these things, there are many other methods to really define the connectivity. But ultimately, there could be a backend automations that can be taking place, so that we can check that if you do have the active edge in your site, I will be able to advertise the routes from this site itself. But if let it be this activeness move to the another site, then the network advertisement can also move accordingly. Now, this is something which you would expect in the lab. So without wasting our time, let's try to log in and let's try to understand from the infra point of view. So let me first of all log into my VDI where we have set up the clusters. So if you take a look on this infrastructure, this is that cluster which I was talking about. So this cluster, just like in basic vSphere clustering, you have to configure it. I have added one of the ESXi host, which is on site number 1. In fact, when you will take a look on VM kernel adapters, it does have a VLAN 6 on it with different subnets. So this is the management connectivity. Similarly, with the KCS side, this is again a different subnet. So though they are in two different sites, it is basically important that your vSphere should be able to connect to your ESXi's. So to put them into one set of cluster. And the same network I have also used for the vMotion purposes. So if you take a look on another VM kernel, it does have two services, vMotion and management. because vMotion can still work on the routing environment also. So this will be useful when you want to move your VM from one location to the other locations. Obviously, if it would have been a layer 2 network, it would be a faster way of doing the vMotion. This is something which you have to really think about from a design point of view. But coming to the pure set of configurations, so when you take a look on the data store, on this particular ESXi, you will see the identical data store will be also mounted on the KCA ESXi. So in this particular lab, we have saved all our VMs data store on this particular data store itself. So when you take a look on it, what are the VMs which is part of it? So it is across all the VMs which I have attached to it. So what does it give us the feasibility? It gives us the feasibility of moving your VM across your site, but this data store is being accessed by both of our ESXi. So um, if one of the ESXi goes down, still these very VMs can be recovered on the other side. So that is the feature what we are going to get with the pure storage. So coming to the fact, when we do have KCA side, again, you'll see that the same data store is being formed over here. Obviously, you can have a lot number of features that can control like which ESXi will have which preferences to what data store. That are the things that you can still configure there. But as from the clustering point of view, it is pretty straightforward. You just need to make sure your DRS is switched on. You do have both of your ESXi's in the cluster, start to deploy your VMs. Now, from a VM point of view, I have got a couple of Linux VM. One is in HRC location, and one it is in the KC location. So if I'll go to VM01, as you can see, I'm able to ping to 1.1.1, which is actually present on our routers that we have configured for this labbing purposes. So I do have the connectivity. Similarly, when I go to VM02, I do have the connectivity. Similarly, if I try to check the cross connectivity across the site, 192.168.200.11, that is VM01, you'll see there's a timeout of around 3 to 4 milliseconds. So though they are in the same subnet, same virtual network, but the location is in two different locations. So this is something logical segments that has been created under the same DVS. So when I'll show you the construction of the DVS, we have got a separate DVS for that. This is that one. And under this DVS, you'll see this is that very network which we have constructed with the help of NSX. So when you take a look on the NSX part, these two VMs are on the same network, but actually this communication is happening between the VTEPs of both of our ESXi's. So whenever you're trying to configure your VTEPs, make sure that they are able to communicate to each other. So when you take a look on the VM kernel adapters, you're going to see that I have made sure that they are part of a same VLAN, especially to just keep in case that I do have a cross connectivity with the same VLANs across other sites. Same way with the KCA site also, it's all in the same sets of VLAN, and they are able to form the VTEP to VTEP communication. So ultimately, from a VM point of view, they will not ever know that they are actually crossing a boundary of networking on the top, because this VTEP communication is making sure I do have the single site connectivity. So this is something a fact between the sites, but as I was explaining, when you take a look on 1.1.1 connectivity, I do have a long timeouts from VM02 because it is now going to active edge sites. So who is actually active edge? That is present on the another site itself. So if I try to explain this part once more, you're going to see that this VM02, it is basically not touching to the standby edge. It is moving that traffic to the another site and it is reaching to active edge and then it is reaching to HRC router. So ultimately, from an application point of view, you need to make sure that what is the timeout that you expect across the VMs so that the application clustering can be still formed. So it doesn't matter for any customer to keep the VM at any of the location, because if I'm trying to see this network as being connected across two high availability, we need to make sure that the VMs are being located at two different locations. Then only we can achieve the high availability from an application point of view. Coming to the fact of the construction of HRC router, it's pretty straightforward. I've formed the BGP connectivity. So if I take a look of show IP BGP, you're going to see that I'm getting the advertisement of 200.0 network, but this advertisement I'm getting from 231 next hop, which is basically our edge number one. And this edge number one is present on HRC side. Same way in the KC side, if you're going to see show IP BGP, you're going to see that I'm getting the same advertisement, but this I'm getting from edge number two. And just keeping in mind that NSX is forming an active standby. So the standby edge is present on KC side. So it is making sure that the AS path is less preferred over here. So on this advertisement, you'll see that they are preparation of the same AS 4 times. And this is a way how NSX forms the active standby BGP network advertisement. So ultimately, from NSX point of view, you're not going to really observe that I'm into two different sites. So when you take a look on the tier 0 router construction, which is this tier 0 gateway, you'll see that I'm going to have these two VMs that is on a network. We know that this network is across two sites, but from an NSX point of view, this is a single cluster itself. From a tier 0 point of view, I do have 231 that is in site number 1, 232 that is in site number 2. You can have another sets of network, and that's going to really come up with a play of the logical routing on it. So this is going to really play when you're going outside of the network environment. But typically your applications does have multiple sets of network. Your ESX size will have the logical router, which can still create the logical routing within the kernel level itself. So the traffic is not going to pass out of the ESX size, and still the routing can be achieved. So this is something which is going to benefit a lot from the traffic pattern wise, and that are the real benefits of having NSX on the hypervisors. So let's try to test how the high availability is being formed across our sites. So just to do the testing, what I'm going to do, I'm going to keep the data traffic going across both of the VMs. I do have KC router and HRC router. This is just for the labbing purpose that I've created these routers. In the real environment, you're going to have either firewall or maybe some Tor routers on the top. I don't want to do the failover of this HRC router, because if I'm going to form this failover, I'm going to have the duplication of the IP address, because this is just for the labbing purpose. I have created these two routers. Because in this cases, you will see that I have defined the same IPs on the same sets of VLAN. But again, from an edge point of view, it is forming the BGP neighborship to the top routers. So this is something which I'm going to disable. I'm going to shut it down, because I want to make sure that this active edge, it moves on the other side. But when it is going to move, it is going to call it as a standby edge, because what we are going to expect, the moment this site goes down, the standby will promote himself as an active site. And whatever the traffic which was going from VM02 to site number 1, that's going to transfer through the standby edge, which has moved to the active edge. And the traffic pattern will still go on from there. Only the thing is that during these transitions, we need to make sure that this subnet advertisement, like if you do have the MPLS connectivity on the top, this network advertisement gets via this other sites. as well as whatever the public IPs which has been provisioned for this particular customer, that need to also get filled over. Obviously, these things will be taken care if this whole site goes down. There would be an automatic network advertisement policies that will be written. But this is something which you need to always plan, because on the top of the network, things has to be automated in such manners. But let it be, if customer want to really use the feature of GSLB, even that is also a viable option that can be used, where you can have both of the edges as an active edges. You can have two different public IPs of two different sites, and you can still deploy GSLB on the top of it. So when you see an application, the application can be reachable via any of the sites. But always remember, the egress features is going to be controlled by NSX, but the ingress feature is something which will be defined by your policies, which is going to be written on the top. So what I'll do, let's try to do the failover task. What I'll do, I'll first of all log into this KCA ESXi just to see that how many VMs that is present on it. Obviously, I know that under it, we are going to have only the KC related VMs. Just for this lab, we will just focus on these three VMs. Other VMs are just for the labbing purposes. So let me just go and log into it. You'll see these VMs are there. For this particular demonstration, what I'll do, I'll try to just put this host in the reboot state. So I'll just reboot it. What would happen when I'm going to reboot it? The KCA ESXi will get to know that one of the ESXi has went down, and as a part of a cluster, I have to recover all the VMs which is part of the HRC. It will be able to recover, as we know that it does have the same data store mounting, and it can figure it out what are the VMs that need to be recovered on his side. The VMs will get recovered because they do have the same objects across an identical objects, what I mean to say that. So what I'll do, I'll just try to go to the power. Let me just do one more thing. Let me go and run a continuous ping. All right. And let me go and power cycle it. So I try to test. Okay. And we'll just keep a note on VM02. Right now, the timeout is around 3 to 4 milliseconds because it is moving to HRC site, but that site is getting down now. So at any moment of time, we are going to see that it's going to transfer to a lesser time period, because the edge, which is in this site, that's going to say that I'm now the active one, and you need to make sure that the traffic should reach to me. So from an application point of view, you need to have an high availability. Now you can see that it has moved the traffic to this particular site itself. Okay, so this transition happened. Okay, when you go back to the Geo KC router, you will see that I'm getting now the advertisement with a lesser AS path, because the edge, which is down under to me, it has become active from NSX point of view. Okay, that's a good thing. In some moment, we are going to see that the VMs are going to recover, but I'm not going to recover the HRC router because that's going to form the duplications. So it went down. Okay, so from a app point of view, I know that VM01 is going to get down, and it's going to get the power cycles on the other ESX side. Yes, now you can see that the VMs came up. Okay, it is trying to come up over here. That's good signal. I'm going to just shut down this Geo router, HRC router. I could have actually put them into a different data store where it is not under the active cluster. But yeah, VM01, it's coming up. But this time it is coming up where? It is coming on the another data center. All right, so that's good thing. That's a good signal. The beams are coming up. Now it got recovered. Now, if I try to go and try to test the connectivity, first of all, let's try to go and try to connect to my VM02. Yes, I do have the connection. And this time the timeout is less because we are both in the same site now. Same way, if I would like to go to my gateway, yes, I do have the connectivity to my gateway also. So yes, I would also will be available from an application point of view as the another redundant VMs. But from app point of view, VM02 was still up there. So ultimately, from an application, you need to make sure both of the VMs are spread across to the sites. Then only you are going to like achieve the high availability across your sites. So this is something that you have to really think about, design it. And obviously, these things can be controlled by the anti-affinity rule. You do have the host rule, grouping, and many other features, which will make sure that the edges are present on the related sites where you are looking out that your activeness should be there. But yeah, this is something, a cool feature that you will see from the recoverability wise. Um, as we have done the reboot behind the scene, this ESXi is getting power cycled. It's going to come up, but remember that the VMs which has been located to my site, it will still stay in my site itself. So it's on the administrator or on the VMware related policies that you have written that can move these very VMs to the back to the HRC site. So this is something that you can control. You can define your related policies on it. But this is something which we wanted to demonstrate with you. So to give you the active features of Pure, plus with the VMware, plus with NSX solution. Now, this is something which is being targeted by a lot of customers so that they can achieve the zero RPUs and RTUs, and without any other sets of recovery solutions like your SR and Zerto or maybe VCAPs. So without having many other features, you can still achieve the activeness of your DCs. So this is something can be a great beneficial things when you're trying to design the your applications in any of the VMware environment. I hope this video was informative. Thank you for having me. Thank you.